Yo, 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 everybody. Sorry about the slow start. Needed to get some things in place. Okay, I wonder if today is the day where we move on from fluid simulation to fluid visualization. Hopefully. Good morning, E-Dragon. I think we're pretty close to a good result. Let's take a look real quick where we're at. Yeah, I mean, it's in an acceptable state, except for one thing. And we're gonna get to that one. I think the last case I want to get rid of is something that looks like this, I think. Yeah. So at this point we pretty much create yeah, in this case, if we don't look at the visualization we got going on, the algorithm visualization, if we pour water here, we won't end up with any water. The green one here will render as 0. CoolerSK getting some yawns in place, yeah. That type of stuff. I needed to fix my my tea I'm gonna drink for the day, and my lunch. But anyway, so if I add water here, we can see that we should be getting more water here, but we pretty much traverse this area. We reach a place where we can't get over with the amount of water we have. That place gets marked as highest point. And we get a final fluid amount that is highest point minus height, and these are the same, so we get a fluid amount that is 0. This part here is something I tried to add to hopefully fix this issue just before I ended yesterday's stream, but I got it wrong a little bit. So we're gonna see if we can fix this, and then we're gonna clean this fluid solver up, and then we're gonna change the mesh in such a way that it visualizes water. I think, although when we do the final fluid walk, we will probably need to find the edges as well. So that's what we're gonna do. Fix the issue, find the edges, make the mesh represent the water. I think it's gonna be beautiful. Unless, of course, we find some edge case where the fluid solver fails finding a stable state, and we have to do that. But we'll see. That's the plan, at least. I'm just gonna run real quick and get a cord for my headset. So 1 sec. Okay, back. Sorry about that. Omega Killer, Unity question mark, Unity exclamation mark. That is correct. That's fine. I was by TV in another room a few moments ago, and then the news host lady was totally yawning through some of her speeches. Yeah, that's a professional for you. Okay. So basically, basically, we get a fluid amount here that is equal to this fluid amount, and then we walk that fluid amount in this area. We get to this stop, and then we also have, then we will have this one as the lowest unreachable node. So this one. Although I wonder if I just want to do this first of all to see if we get the correct lowest node. So let's take and let's just print it as black. Get a chord. Isn't chord the correct word? Like a chord to charge something? And you might be happy to hear this Cooler SK, but I actually have tea right next to me. I have around 1.5 liters of tea, I think. Chord, not chord. Hey, do we not get the highest point here? That's weird. Omega Killer, nice. Man of Tea, hell yeah. Love them all. Black, green, red. Although I think green is my favorite. Okay, we don't. What the fuck? Do we never get to this one? Green is my favorite for most occasions also. Yeah, it's extremely nice. E-Dragon, join the game jam with the theme opposites. Two characters mirror the controls of each other. But holy shit, creating a level design for this hurts my brain. Yeah, sounds like a problem. I actually had a similar... Fuck, I actually did something extremely similar to that one for a game jam. And yes, the creating the levels was by far the hardest part. I think I only have 6 levels, but in this game you control a blue ball and you want to get to the hole. And at later levels I actually introduce a red ball that moves the opposite as the blue. So kind of similar. Lowest unreachable point should always be M at least. So why are we not getting it? Oh. Oh. Yes. Do we actually get to this one? That makes sense. does it? Now we should draw it here. Not seeing it though. Okay, we probably spawn this one and then fuck it, let's go for 5 seconds. So before we start spawning green cubes, we're gonna spawn a black one. Hopefully it will mark binary land from Ness. Ooh, I've seen this. What? If n height interesting issue. One thing bothers me here. Yeah, final fluid becomes... Yeah, I think we enter this one. Yes, we do. Okay, so this one is... Okay, so what happens here is that 0.1 fluid ends up here, and when we start walking like yeah, when we start walking like this, we find an unreachable node. I have to make sure. It's we're aiming for a slow start today. Okay. So we do get to this one. Highest point height. This one should yield 0. But how the fuck can this one yield 0? That's weird. Ah, if we don't add fluid to it, and okay, so else if new fluid amount is less than 0, that it might very well be, it probably is. And if this one is less than building graph's error margin, this shouldn't be true. We should get to this point. Yeah, I don't see us getting this. Lowest unreachable point height minus m height. Yeah, that's correct. The fuck? Come on. So for instance, we can see here by the dark blue that we traverse to this point. When we try to traverse this way or this way, we should be getting a neighbor, which we can't add water to, which has a higher height than this one. Definitely. So what up? Okay. I guess, like, this isn't really that huge of a problem. The only difference is, like, if we pour this much water here, I would assume more water here. Yeah, we never enter that if statement. Yeah, okay, so we never change this one. So my question then, this one is extremely small. So that should never happen. We try to add fluid, we can't. Oh, although, yeah. We try to add fluid, we can't. We jump down to this one. New fluid amount should definitely be less than 0, so that one is true. P height minus N height. The neighbor should have a bigger, way bigger height, so this one should be quite big. Building graphs error margin is... Building graphs error margin extremely small, so this one should be false. So we should enter this one. Then what the fuck? I know. Yeah. Lowest unreachable point is M, so the first time we get to this one is way... Yes. Lowest unreachable point... Fuck, we can't set it to M first. Of course, that one will always be the lowest. Simple mistakes. So lowest unreachable point. I could set this to null, but then if we do that, we're going to introduce the need for a lot of if statements and such, and I want to avoid that. We could set it to, instead of having it as a fluid point, we can just set it to a float, which is probably the better decision, I would say. But if we do so, fuck it, let's do it. Float lowest unreachable height. And first we're gonna set this one to m.height plus m dot building graphs fluid amount. And here we can just do if n height is less than this, lowest unreachable height, n height, and here we do n, and then we do lowest unreachable height. And that's just to make sure that we don't overflow. And actually, if we have this one, this one might possibly not be needed anymore. But let's see if this one works first of all. Still. Yeah, that's probably not true either. Ah, yeah, this could... Yeah, this doesn't have to be true either. So what the hell can I base this on? I wonder if it would be safe to do this. Then this one would hold true. A little bit skeptical to this one. This one is correct, definitely. But why the fuck is this one unreachable? It doesn't make any sense. Or actually... Yes. Okay, so what happens now is we don't succeed. Yeah, I think we go to the highest, or we go in a direction that leads to a terrain that is way higher. This one fails, we enter this one, we set the new n height. Then we move in a direction with the same fluid amount. Yeah, so that's the problem. If we try to move in a direction, if we try to move to a neighbor that has the same fluid amount as this one, then this one fails. This one also fails. We enter this one, and yeah, we're screwed. Could add an additional condition to make sure that it is not filled with water at all. Yeah, like if n dot building graphs fluid amount is less than or equal to 0.0, or just less than building graphs error margin. Maybe. Feels kind of weird to have built this multi-step fluid solver and this holds us back, but yeah. Thank you. But then again, I want to try environment final fluid base cost 0. Nice. Oh, beautiful. not so beautiful. But the result here is not that bad, assuming we pour extremely much fluid at this point. This is probably something you would expect. But I saw some issue with the algorithm at a stage I didn't really like. I think it's here. Also beautiful result. Actually, let me remove this shit. I also think we have a case where if we find a minima, I don't know, let's see. I like that. I like this. I like this. This one, I like it. I think we want to support something like this. Can't be perfect. This one is probably it's okay as well. I wonder if we can probably start cleaning this one up and deform a mesh based on the data. I'm starting to think it's time. But Actually, we have... Currently we don't have any costs related to moving downwards. I think we're gonna add a cost in our initial... So the light blue pass of the algorithm, I think we're gonna add a cost to moving downwards. Because... the problem we get here is related to moving downwards, because we move with a lot of water on the sides here down. I don't like that. We're gonna add a cost to we could probably make it in such a way that we add a cost multiplier to it that is based on distance from source. In practice we have something like it. Maybe not for the first iteration. Yeah, we do when we move in parallel. Okay, so what do I want to do? I want to do... Proyask, what's up? What's up? This is a thing I want to figure out as well. Why are these... This is probably just an error in the visualization, but why are these white boxes still here? White should visualize the active one, and we have it... Fluid test active color. We set it here. We set it here. We set it here. And we set it here for some reason. Yeah, that's okay. Yeah, I'm pretty sure it's this one that gets stuck pretty much. Proyask, where are you from, by the way? I'm from Sweden. In the north of Europe. Yeah, okay, so I think it's this one. But this one should fix it. Could be this one, and if it is, that sucks. Ah, yeah. What's the game about? It's about taking care of a garden by terraforming it in such a way that creatures wants to come and live in your garden. And right now we're working on the terraforming, or more specifically the water terraforming. Oh, beautiful. Beautiful. I think there exists a lot of room for performance improvements in this one. That's for show, but Pro-Yask, any reason for the retraction? I think that was a it was a good question. Yeah, we can definitely see here that this is exactly what we wanted in the way of not being realistic. Like if we pour water here into this area, we would never get a result like this in real life. This one is the minima. It's the lowest point, so water should collect here and dry out this one. But this is how I want it. Like, for instance, if maybe I want my player to have, if he or she has this terrain, maybe the player wants to have a high point here. Let's see, like this, or like this. What the fuck? That was unfortunate. Yeah, more like this. Although I wonder. Graphics looks nice. Thank you, appreciate it. And no, the idea is not to add multiplayer. Unfortunately, like, it's outside of the scope. It would take too much time initially. Yeah, I think this is nice. Yeah, so for instance, the player should be able to add a high point here and get something like this. Ooh, one more thing. Yes. Yes. This I want to fix. Gotta go now. Thank you for dropping by. Appreciate it. And you're welcome back if you want to. So what happens here is that we find this one. This is the lowest unreachable point. And we just fill the water up to that point, which is wrong. I forgot to do, so here, final fluid amount, invalid, final fluid amount. We want to Here we calculate the fluid final fluid amount based on highest point minus height, lowest unreachable height minus height. We need to check here. This one, we don't want this one to be bigger than this one. If it is, so I guess we're gonna do possible final fluid amount, possible new and then we do if possible new fluid amount is less than final fluid amount. If possible new fluid amount, okay, possible new fluid amount, if this one is less than final fluid amount. Yeah, so it's basically, is our fluid amount thresholded by its surrounding points? If so, lower it. Prosto, what's up? That should hopefully fix this issue without nullifying the previous fixes. Definitely. I hope. Yes, beautiful. Ah, nice. Love it. Love it. I want to try. How's your water simulation going? It's going pretty damn good, I would say. I think we got it. Welcome back, Pro Yask, I suppose. What the fuck? Did I hope I started a second. This fucking problem again. What the? Okay, no, never mind. But still. The end result is still good, but we can see that the algorithm is screwing up a tiny bit at a specific point, and that irks me. So at that point, what? Yo, what's up, Derek? Epoch, what's up? Where can I learn game developing skills? Can you suggest? Choose an engine, and then you can check out their official stuff first. I think that's pretty good. So Unity themselves has pretty good getting started tutorials, Godot as well. And that's not to mention all the great creators on YouTube and such. But for instance, when I'm learning something new, for instance, when I started working in Godot, the first place I went to was their official webpage. Whoa. Whoa, 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 whoa. Mr. Quote, what is the age one is when in 10th grade in India? I'm just trying to get a reference point. We could see here that for some minimas we get the end result is always good, I would say. Here we got fucked. Why? Why, oh why, oh why? Why? Mr. Quote, my age is 15. Okay, nice. That's a good age to start, I guess. Yeah, if you haven't done much programming previously, I also think Python is a very good starting point. But who am I? I'm only a guy that fails implementing a fluid solver. Why, oh why do we get this case? I need to figure that one out. So we can see that the neighbors, the second pass of the algorithm, gives us a higher water amount here than this one. For some damn reason, we're lowering the water amount here, and that is because I don't know. I have no fucking idea. Such a special case as well. Possible. So what happens is final fluid amount. We take building graphs fluid amount. We can see that it is bigger. It is. Invalid end nodes. Yes, yes, yes. I know what's happening, I guess. Yeah, I do. Okay, so what happens here? I'm pretty sure is I think I can recreate it by doing yep, but then we get saved. What do we get saved by the second time around? I think the issue is, yeah, when we start walking from this one, we get to a point. Do we? Let me do this. Spawn fluid visualization object and add to dictionary. This one. Spawn. Did you need an editor for your YouTube videos? I did it them myself. So what I think happens is we get to a point where all the water disperses, which means that we will get a zero amount basically, and that's what we want to happen. But we get a result. Yeah, I think I don't want to fix this. We want to do instead we want to do new fluid amount. This one can become 0. So we want to do if let's see what happens here. We do yeah, basically what we want to do is if final fluid amount minus So pretty much if the final fluid amount is 0, we break. And the one we break is this one. Yeah. But then again, should be about right. When the game is going to release, that, Mr. Quote, I have no answer to. Not in a while. Okay, so we get 0 water here. Yeah, this is not enough water to fill this one up, but I think that's good. That's what we want. Oh, beautiful. Mm-hmm. Yeah, that one is also okay. We don't get enough water down here to fill this one up in that case. But when I think about it, are we going to add economy in the game later? Yes, we definitely are. Okay, yeah, I think we're at a state where we're gonna do this. We're gonna clean up the result here. We're gonna run the algorithm. We're gonna calculate our final water areas. And when we calculate those, we're also gonna calculate edges, because the edges we're gonna use to we're gonna use them for, like for instance here, when we that's not water, but for instance, can I find, basically we want to get the edges as well, because we want to base the mesh on those edges, because we want the water to disappear into the terrain. We don't want it to we don't want it to seems like it's floating, you know. So yeah, I want to clean up the algorithm result and calculate the edges. We can probably calculate the edges when we do this pass through, but that means that we will need additional an additional list. Yes, so the idea in this game is that the player will own at most this plot of land, I think, and then needs to cultivate it. And of course it's gonna cost money to cultivate it, but it can also earn you money. Okay, so first of all, what I want to do is let's see here. I'm weighing the different options. Like we want to get a clear result, but I also want to clean up the code. Yeah, we're gonna go for a clear result first, and then we're gonna clean it up. This one leaves us with the graph is the final result we have, and I wonder, fluid point, fluid group. Jacoby, appreciate it. Enjoy, enjoy. So basically, what we want to do here is we want to save this graph as a body of water, basically. Yeah, that's what we're gonna do. That is what we're gonna do. Fluid point, fluid group. Alright, Mr. Quote, thank you so much for stopping by, appreciate it. And have a great rest of the day. And I wish you good luck in the future as well. So I think we're going to introduce fluid group. Maybe something I should have done earlier. We can probably use it to clean it up a bit. Oops. Fluid group. And let's see here. Can we do this as a struct? No, no. Entry point points. I think we're gonna do some additional stuff with this one later on. But for now, this is it. And instead of creating graphs here, So when we exit this one, we want to have a set of yes, when we exit this one, we want to have a set of group. I wonder. While break. Yes. So it's after this one. Instead of doing a graph, we want to do fluid group is equal to new fluid group. Starting point is M. Starting point is M, fluid group. We also want to do points. Yeah, let's do fluid group. Then we do this. Yeah, we do this. Okay. Whoa, whoa, whoa. What the hell, we can just name it P. Remove, but one more thing. Fuck, do I want to do this earlier? The thing here is let's see. Basically, we can, in some of the worst cases, we can have a fluid group. We can create a fluid group, but then we create a second fluid group that pretty much takes over the previous fluid group. and we want to avoid that by doing yeah, so what I'm saying is each fluid group should have, we shouldn't have a fluid group that contains a point that is an entry point to another fluid group. And this could possibly be fixed earlier on, actually. Oh, yes, it could. Okay, now we haven't really changed anything, so we might work with this one later on. Yeah, I think we want to do final fluid amount . Have to double check a case where this happens. I need to know exactly why it happens. Like, we want to start with the minima. Let's see here. Yes, here we have it. So in this case, we start working with this minima because it has the most fluid. But this minima (0.3, 0.3). Ah, is it only a case? It might be where we have the same amounts. We picked the wrong one. Yes. So this might just be a problem of doing a secondary sort. (0.3, 0.3), yes. Oh, beautiful. Yeah, I think we can solve this pretty easily. Apok, I'm watching you for a while. First of all, thank you, appreciate it, but still don't know what will be the end result of this liquid implementation. That's hopefully something we will clarify today. The idea is that the green boxes here is the end result of the algorithm. So that is like if the player adds fluid here, the green ones represent where the fluid will end up. And the idea is that we will take these points and we won't make a mesh out of them, but we will alter an existing mesh such that we have a mesh much like this one representing the water. So what we're doing here is like nowhere close to a real-time fluid simulation or anything like that. We just want to be able to add or remove water from a landscape and calculate stable states for it and visualize it. Maybe not the best explanation, but hopefully it will become clear soon. Okay, so what we want to do here is we have a case where we find minimas with fluid amount, and then we order them by descending, finding minima's fluid amount. So we take all minimas, we order them such that the minima with the most fluid is first, and then we start looping through them. Unfortunately, in some cases we get two minimas that has the same fluid amount, but one of them is higher up. But since they have the same fluid amount, we sometimes pick the one with the lower height, which means that we will parse points. We will parse the wrong points, basically. Or we will parse points 2 times. And we want to avoid that. And I think we can do it by descending m dot finding minima's fluid amount plus m dot height. I think that's how we want to do it. Do I want to write this as this? Order them by most fluid amount and then by fluid amount plus height. Although I'm still a bit annoyed why I haven't figured out the case where this one shouldn't be the correct one from the get-go. So I guess those squares are going to be removed and you will only use their position. Yes, exactly. So these squares we're seeing are just a debug tool, basically, to visualize how the algorithm works. And now I think we picked the right one, and then we fill it with water. And that's beautiful. And then we fill this with water. Yeah. Yeah, now we always pick this one. Although, I want to try. Let's see here. Oh, beautiful. Ooh, we don't get any water here. Yeah, I guess that's correct. So we have this one, fluid amount 0.3, 0.3, but this one has a height that is 0.52, 0.27, so we should choose this one. And there we go. By doing this, this means that we will never end up, I don't think we will ever end up with a fluid group that contains another one's minima, or another fluid group's entry point. So what we're going to do now is we fix these fluid groups, and then in the end here, algorithm step 3. Clean up, possibly. So what I want to do here is we're gonna start by doing private void clear fluid visualization dictionary. So the first thing, let's see here. I think we can wait with this one. The first thing we want to do here in cleanup is this. Because now, so we want to clear everything we have seen the algorithm do, and now we will only draw the final result. So for each fluid group in fluid groups, for each fluid point in, yes, spawn fluid visualization object and add to dictionary p fluid amount think that's about it. We're gonna add one additional. Yeah, we're gonna print some additional stuff there, but I just want to see this result first, and the final result I want to make. Why not? Okay. Oh yeah, we never add anything to the fluid group. That might be a good thing to do. Fluid groups dot add fluid group. Okay. A little bit worried about that one. Did we go through this one twice? I think we did. Yeah, we did. Well, let's see here. And not in this case. Zero 0.41, 0.14. Yeah, we can probably balance the costs of this, make it a little bit nicer as well. Avoid this. I think we're seeing pretty good results here. This one though. We loop through it twice, which sucks. So what I think will happen, what I want to do per group now is that I want to calculate edges. Since we move through this one twice, we're going to get some weird edge in between here. And I want to get rid of that. Yeah, but we will see what happens. Let's do it. So when we create a fluid group, we want to add edges. So group, we have points, we have fluid point edges. And an edge is if we fail by adding fluid. In fact, now I want to rename this one. Add point, add edge, if okay, so now we add edges. Unfortunately, there might exist a scenario when we add an edge, or when we add a point here that has already been added as an edge. That just means that the initial path we took led to this one being an edge. The secondary path did not lead to that result. Wonder. We have the same thing here, but here we just need to check and edges doesn't, no, not edges. Like this. Points does not contain edge. I think that's how we want to do it. So if we don't succeed in adding fluid, then we want to add this one as an edge. But we add this one here. I think that's good. Or yes. So now we add edges as well. So we have edges. So for each fluid point edge in edges, end result yeah, here we want to add 0.2 maybe, 0.5, and end result edge color. Oops, one sec. Yes, I know what went wrong. I was gonna drink some coffee while watching this algorithm finish. But yeah, we forgot, or I forgot, to instantiate it. So let's see. This is an overflow I support. I love it. This is good. I want to change the color of these though. Ooh. Did we actually? Yeah, we did. This is probably also a too big of a spread for the initial the part 1 of the algorithm, so we probably want to skip that later on as well. And I'm pretty damn sure that, yeah, we'll leave this one in a cleaned up, acceptable state, but we will probably find more edge cases along the road where we want it to act different. Yeah, here we have one of these issues I spoke about. It's not too bad, but I don't want this to happen. And the problem is, fuck, I've done this previously, but I want to try it again. In my mind, we should be able to by the way, I think this is the longest method I've ever written. Game deving ever. Hopefully we can minimize it though. Let's see here. When we do order by here, I don't know why this shouldn't be the best possible result we can get. So order by descending would take finding minimum fluid amount plus height. So after the initial pass, we take the point with the highest surface height. Why? Maybe I did something wrong previously. I don't know why this wouldn't work. Maybe I do. Yeah, I think I do. Here it works perfectly. Ooh, we don't actually... Yeah. Why? The fuck? This one dries up, that's true. I'm starting to think this gives a better result. Or, yeah, it does. Mm. This point had height plus fluid amount was higher than this point here, but when we traverse from this point we lose water until we get here, and then we can't enter. Yeah, of course. Is that something with the rule set we have? If we tune the values, the costs, like, the problem stems from the fact that I'm assuming we're trying to sort this in such a way, in such a way that the one with the most reach is first. So I'm assuming in this sort that this one has a bigger reach than this one. Unfortunately, that is not the case, and that's why we get this. So we can't base reach solely on height plus water amount. Because when we move in parallel, we dry up. We could, in the cleanup phase, we could get rid of these overlapping edges pretty easily. But it would be pristine if we could do it earlier. To minimize calculation amounts. This doesn't happen very often though. So I guess we're gonna start walking from here, but we won't reach. Oh, we have two algorithms working right now. Mm-hmm. Yeah. This doesn't happen very often, so I wonder if I'm gonna leave it for future me. Or get rid of it in an ugly way now, and then pass it off. Or just leave it. Because what we want to do in practice with these edge datas is we just want to set the fluid to be equal to its neighbor, basically. So I want to do this. Let's see. We're gonna exit, and before we do any changes, I'm gonna set this color, and and we're gonna do this. Where do we have it? Add edge. Fluid group add edge. So if this one fails, what we want to do here is n dot if n dot add fluid amount add fluid amount, and the fluid amount we're gonna add is so if we find an edge, or if we can't add water fluid to it, then we try to add the same fluid amount. First of all, we don't add it to unvisited nodes. This one is an end node. But yeah, never mind. I don't want to use this one. That might lead to some issues. Or can it? It might. Maybe. No, I don't think so. So yeah, then we just add that fluid amount to it and we're done. Fluid amount. Let's see what we get. Yeah, we get this. I was afraid of that. Okay, yes, so we can't use fluid amount here, and I'm not too sure. I don't want to introduce a new float. Okay, we're gonna do yeah, the problem stems from we might find an edge here if we walk a certain path, so we add fluid amount to it. It's edge fluid amount, but this one might very well already exist in unvisited node, so the next time we get to that one we have more fluid in it than we should. Yeah. We could use some of the old values we have, or Hmm. For now, let's just do... Should hopefully work. Okay, great. Okay, so the next issue. Currently fluid amount at a position in the texture refers to the actual amount of fluid at a certain position. I'm starting to think that it should actually express the fluid height above sea level being 0, to make it easier for the mesh. So before we print this one, I want to do or when we visualize it, I want to do this. Let's see here. When we visualize it, or actually fluid point, set raw fluid amount. We might want to rename this one, but here we change it to nah, that's not what I want to do. Instead, what we want to do, when we spawn visualization, we want to set this one to 0.0. Position is equal to position world space. So I want to add position here, and we wanted to add it to so let's see, is this somewhat correct? We want to spawn it at position. In the X and Z, we want to spawn it at the correct world position, but on the Y, we want to spawn it at raw fluid amount, which now has been set to position above sea level. That's not entirely correct. Fluid amount, because it should be Yeah, so raw fluid amount is between 0 and 1. Fluid amount takes the minimum and maximum height of the terrain into account. So I think this is what we want to do. Not exactly. Set raw fluid amount. Edges we still need to fix. But that's not the only problem. Why are we getting a lower value for these? That's weird. Yes. Of course. Fluid point, what we send in here is the actual amount. So what we want to do, set raw fluid amount. I wonder, is this the correct way? No. It's a question of, or I've come to a point where I need to decide if water per pixel, or like per position, if the water value will represent water amount or water surface height. Water surface height is something we can calculate, like, fuck, we can do it the other way around as well. Both of them, with one of them we can calculate the other one. But when we draw the mesh, when we draw the water mesh, we're gonna draw surface height. So if we store surface height, we don't need to do any additional calculations. If we store water amount, so apart from during the fluid solver stages, I don't think we will ever need water amount. Or we went with water amount previously, so maybe just leave it at that. So yes, this is at the actual amount. So instead, when we want to print these, we can do terrain data dot get fluid surface height. We don't have raw, or we don't have fluid surface height though. Terrain data container raw fluid amount, raw fluid surface height. Although, yeah, it will be way easier to recreate the mesh later on if we go with this, I would say. And that's not where we want the edge point. The idea I'm having is that we're just gonna, after the fluid simulation, we're just gonna write it to the texture, and then in our water shader we will read the texture and offset the vertices. Although That might be more costly than we would like unless we actually instance. We'll see. Because then we need to store surface height from sea level if we want to get the edges to work. Yeah, because the result I'm looking for here is something like this. Let's see. Train data set raw fluid amount. Not here, but so when we set the fluid amount, we do raw height plus edge fluid amount, and when we do edge, we just do edge fluid amount. And then when we print it, that means for edge points will have a fluid amount that is, so a fluid surface height above sea level that is lower than its height. I think. Which will lead to clipping like this, which we're gonna have to handle, but that's okay. We're just gonna add a tiny offset in the water shader, I think. What the fuck? This is fucked. Yeah, it is. Are you serious? Yeah, we broke it. Yeah, of course we did. Or I did. Set raw fluid amount. Raw height plus fluid amount. That should be correct. Edge fluid amount. I'm a bit more worried about this one. I think this one is correct now. Yeah, the one we want to set here is fluid amount. So when we, yeah, we're gonna have to do some deep cleaning here later on in the code, but this one is fluid amount, this one is fluid amount, this one is fluid amount, this one is fluid surface height. Fluid group, add edge. Add edge fluid amount. Yeah, pretty sure this is what we want to see. Yeah, I think we can create a mesh out of this. But oh, this is beautiful. Yeah, we need a tiny bit of an offset there, but yeah, this is beautiful. This one, however. No, this one is okay. I don't care about that. Although this one is not correct. Yeah, we want this one to be lower. Yeah, this one would be okay as well. Yeah, we're gonna have to do some shader magic for this one, because if we distort this one, we're gonna see the edge of the water. Although, never mind. Never mind, we're gonna... it might look cool actually. We'll see. We'll worry about that later. The only thing that worries me right now is this one. The problem is... this one detects these as edges. This one does not. But since this one detects it as edges, this one sets the fluid amount in it to be higher. I'm not sure. Yeah. Height, fluid amount. Yeah, definitely. Or? Yeah, that's the case. Okay, what happens is that this one sets the fluid amount. Oh, this is weird, yeah. This one sets the fluid amount. It's just a regular fluid for this one. This one marks this one as an edge, so when we draw it, we do it by this one. But the fluid amount it draws is actually this one. It's not entirely sure what's happening here, but I think that's the case. I need to check. I don't even know where we added the water, probably here. No. Yeah, we have a similar case here. Yeah, I think this one doesn't mark this as an edge. This one marks this as an edge. Okay, we need to handle overlapping edges previously. We're gonna do it in an ugly way, I think. We're gonna do it by... We're gonna do it by... We're gonna do it like this. Step 3, clean up. We clear this one. Before we start filling the fluid groups, we do... If fluid group dot entry point, or actually can we do it like this? If fluid group dot entry point let's see here, if this entry point exists in any other fluid group, remove it. What's the best way to do this? Yo, what's up, Momomit? I don't know if I'm the correct person to answer that question. What types of apps? The problem here is also that fluid group, what do we do? Add edge, fluid groups, add edge. I think we can do like this. I think we want to remove entry point from this one. Definitely do. And then we do if fluid groups dot select many g.points. We could probably do this. Select many. Can we do it like this? Yeah. And then we do if all fluid points dot contains fluid group entry point, then and we throw that one away. It's not pretty, but hopefully we will get rid of edges in the middle of fluid pools, fluid groups. Collection was modified, enumeration of it may not be executed. Yeah, of course. So we modified this one while we loop this one. So do we need to do a for int I is equal to fluid groups dot count -1, I speed equal to 0, I minus. If all fluid points contains groups I entry point, fluid groups remove at I. Loop it from the other side, remove it, yeah. Then we should be able to modify it while we go. Hopefully. So this means that we remove all of them, all fluid points. Oh, fuck. Fluid group. Could we actually do? Yeah, now we might add it. Then I guess we can do if point is not equal to entry point, or Ah, Ooh. I think that's okay. Fuck. Oh, this is way rougher. Opa. Why though? Of course it is. Of course it is. What the fuck? I didn't think about this one. But for instance, when we draw, if we add... Wow. I think the case, what's happening here is... Oh yes. This one won't reach here, and this one won't reach here. But then they shouldn't include... Yeah, what I think is happening is... This one... Let's see here. Nah, I'm not entirely sure, but I want to get to the bottom of it. But before I get to the bottom of it, I need to just grab something to eat real quick. So be right back, around 5 minutes. Okay, back. Sorry about that. The beat, the art style is awesome. Love it. Thank you. Appreciate it. Okay. So the approach I thought would work does not work. So what the hell can we do instead? We could do something very similar to what we did, but we check for each edge if the edge is included, but I don't know, feels like a hack as well, and it's gonna be costly. So here we will probably get edges, yes. We're revisiting nodes as well. That's not good. Yeah, fucked up. I'm wondering if if we could possibly calculate the edges at a later stage, but that might be a bit too late. Or we probably don't even need to calculate edges, honestly. Let's see here. Depends on how we want to solve the fluid shaders. Because I mean, I probably want to check neighbors. I think that's gonna be costly though. Oh yeah, we no longer add the minimas, definitely. Okay, so there's two approaches to the water. Either we keep it as a plane and just alter its position in the shader, or after the water simulation has run, we alter the mesh once and leave it as is in the shader. That will hopefully help a lot with culling, I think. Okay, I think I know a fault. In the algorithm as well. That might improve it. Ooh. Definitely. Fluid solver. Calculate final graph. Add fluid. What I'm trying to avoid is, or what I want to avoid is probably something like this, I think. Or do I? I have no idea what's happening here. Fluid base cost, what do we have? Final fluid upwards multiplier cost should be 1. I hope it's 1. I'm a little bit like this one right here. What's the reason for that one? Okay, so it's in the final bit. This looks okay. This does not. Terrain data fluid amount. Raw fluid amount, that's the one we set. Is it the truncation? No. Could it be? I want to try and do... I just want to make sure that it's not the... that it's not the floating point resolution that screws it up. So we're saving a value to a texture and then we're reading that value back. We might get some truncation there. I just want to make sure that's not the case. So I want to make sure that the fault is in my code and not having to do with floating point numbers. So we're gonna do terrain patch height range. Don't we have that one? Fuck. Height range, lerp, p dot height plus p dot Okay. Then truncation. Okay. C# float 8. Four bytes. 1632. Unity color. This one is... Now we're running 32. Yes, I'm working with color, I guess. Each channel is 32 as well. Floats. What do we have? C#. Because the best, so in the final product, each water point will be tied to a floating point number. So the height of each point of the water will be tied or constrained by a float or a floating point number represented by 8 bits. And like if we do all calculations with floating points, so with float 32 bits, and then we truncate it, the truncated result might be, is going to differ. So if we would do the float or the fluid solver in 8 bits, that would be extremely nice. But I guess we could do work with unsigned 8-bit integers and probably byte. Then we can represent numbers between 0 and 255, and then we can interpolate it. So we can do math lerp. So if we want to calculate a floating or a float number, later on we can do math f. In fact, this would probably speed it up a bit as well. Do we want to work with byte? Okay, the end result is good. When we later on truncate it, it gets fucked. So I want to do this. We're gonna change this one back to this. We're gonna remove this one. I don't care about edges for now. We're gonna work without edges. What do we have? Add fluid minima threshold fill. Yo, what's up, Fabic? How are you doing today? We could probably do some pretty stuff here, but what I'm gonna do is I'm just gonna copy this full method, and I'm going to copy this full method. We're going to implement add fluid minima threshold fill byte. So we're going to minimize it. How's the progress going? It's going pretty good, I would say. Now we're trying to implement the bridge between fluid solver and mesh. So after the fluid solver has done its job, we want to prepare the data so we can represent it by a mesh in a nice way. And one step in doing that is to work with byte instead of work with 8 bits for our fluid solver values instead of 32 bits. And that's just because we want to minimize the difference between the underlying data and the fluid solver work. So the underlying data is water is one channel in a texture that is RGB A32, so 8 bits per channel. So yeah, let's do it. We might even get some performance out of this. Good thing here, if we implement this one using a byte instead, so we work with integer values, then we don't need to care about error margins and stuff like that. That's beautiful. It might also become a little bit clearer with the costs and stuff like that. But in the process of doing this, everything will be a mess. So let's take this one. And we hide that one. Bam. Beautiful. Add fluid minima threshold fill byte. Terrain patch XY float fluid amount int fluid amount. And then we're gonna add fluid solver mode (31). If we have these two, we can fill it using both compare result and such. Case fluid solver mode byte. And what I want to do here first of all is I want to do int fluid amount integer is equal to, I wonder if we can do this. mathf round to int mathf lerp. Is this the best way to do it? Between 0, 255 and fluid amount. Fluid amount is between 0 and 1. We lerp between 0 and 255. And then we round it to an int, and that's the fluid amount. Maybe. We don't care about error margin. And then we do let's set it up to be exactly the same, but (0.1, 255, 25.5, 26. One multiplier here, so we just want to go with 1. One sec. We actually want this as byte, I think. We do want this one as byte as well, so fluid amount byte. We have to be careful here later on for overflow. I don't know how that is handled. Final fluid base cost, we don't care about this one. Upwards multiplier, it's just going to be 1. Adding byte will overflow. Yeah. Yeah, we're gonna have to handle it. Luckily, we never add fluid. We never add fluid apart from the initial add, and when we do the initial add, we override what's already there. So I don't think it's a good point. Like, we need to keep it in mind, the overflow, but the initial value will only decrease in our fluid solver. Good morning, Dasai. Just casting the rain. Let's just cast it then. Okay, this is gonna be hella interesting. And a nice introduction to byte, because we eventually want to change our terrain mesh data to use bytes as well. Fluid point byte. And we might as well add... Yeah, I wonder, Fabic, I wonder. We want a fluid group byte as well. Height. Oh, we read it from the texture here. Fuck, this is what bothers me. Unity color each channel as byte. Color 32. Ooh, yes. So do we want to do... Yes, that's beautiful, I think. Yes. But still interested in it. Okay. This is beautiful. Although, we have a lot of changes in this one without committing. For now, we're not going to do anything here. But we're gonna do we're gonna do in fluid point byte, we're gonna do terrain data dot data dot get pixel 30. Do we have to get all pixels? Come on. Why? But can we do get pixel data? We get all pixel data as well. I don't like this. It's way harder to work with than I would have hoped. Unless... Okay, so if we redo terrain data later on, we're gonna have to do it with flags and stuff like that. Like I won't be able to get... I want this, but pixel 32. Probably what we're gonna have to do in terrain data is terrain data container. We're gonna have this data here, and then when we try to get value, we're gonna have to check if a flag is dirty. If it's dirty, we need to get all pixels 32 again. If it's not, we just give the ones we have. Jeez, this is rough. Texture 2D data. Unless... Unless we change this one to be a color 32 matrix. But then I wonder how much of a problem it will be to send to shaders. Yeah, this is what we're gonna need to have. We're gonna have to have a native array here. Now it becomes a question if do we actually use this abstraction of texture 2D, or could we as well just change this one to a color 32? And if we change it to a color 32, we might as well change it to a custom class, and we just pack it as color 32. Yeah, we might want to rework this one. What we could do now, because I don't want to do that now, is this is unoptimized as fuck. But basically what I want to do is, why does Texture 2D Unity, there must exist a simpler method for this. Basically what I want to do is, we have this Texture 2D, we have a lot of data in there. The data can vary, like it can be all kinds of data. I just want to get, the pure data at position. Unity texture 2D get byte data at position. There has to exist. Get raw texture data, but then we get all. Oh, bah. Like, I seriously... Let's see here, instantiate RGB A32. I guess that's the most usual one. Like, I do want to convert this one so it's way quicker. Instead of get pixel, set pixel, converting back and forth to color and so on, I actually want to make it work with color 30. I want it to work with color 32 or bytes instead of float. But I don't want to do it now. One sec. So what I want to do now is I just want to get the byte value, but I don't want to get all the byte values. Unfortunately, there seems to be no way around it. So we can do this. And then now's the question, is it column first or row first? And we probably want to use this one, right? Get raw texture data. We can I wonder if I'm supposed to do data dot width plus y, or no. Maybe this one is probably quite costly. I want to know how it's stored in data, because otherwise, could we do byte and then plus what is it, x times data height times 4 plus y times 4 plus c? Like, in what order do we store this? One sec. Okay. If you don't need a copy, or if you want to modify the data directly, native array. Yeah, so we want to do this one. Appreciate the lurk, Fabic, and thank you. Ah, this is beautiful. Okay, so this doesn't cost anything, right? This doesn't cost shit. Get pixel data, color 32. Shouldn't we be able to do this? But then we need to do, I still need to know the order. X times data.height plus y and c. Right. Gets the raw data from a texture, returns a native array that points directly to the texture's data on the CPU. Beautiful. And has a size. Oh, this is exactly what I want. With the only caveat that we need to calculate the one-dimensional index ourselves. Doesn't allocate any memory. Oh, this is everything I wanted. Mm-hmm. Oh, okay, we don't need to do anything. Okay, beautiful. The only problem, this, but okay, great. So it's just that, yeah, Texture 2D doesn't have any implemented method of getting the pixel data given a 2D, or yeah, a 2D index. You just ask for the reference and you convert your 2D index. But let's see. And this I know. What is it? Texture 2D, Unity, column or row first. Wait. Or do we have it on? One sec. Alter raw height. Oh, we do set pixel here. That's not good. Yeah, we can clean this one up. Why am I unable to find this information? What is the correct term for this? Column, matrix, column first? Isn't it column first? Column major order, thank you. Unity texture 2D, row, major order. No, not texture erase. Do we define that ourselves? BGRA. Ah, that's not one. RGB. Yeah, texture 2D is a texture, so we might actually get good things from that one as well. Dimension, graphics format. Okay, can I test this myself real quick? Yeah, we can. Let's do it like this. Fluid solver. Private void start. Texture 2D. What is pixel data, right? Color 32. It should be all black from the beginning. Okay, let's see. I want to change. If I want to change the let's see here. I want to change the okay, what order do I assume they are stored in? What the fuck? What is the standard? Row? So we walk rows first. y times t dot width plus x. Is that how I want to do it? No. Or yeah, it is. If it's row major order, right? Y times width fuck, is this even a good test? Ah, we can just try it like this. What the hell? Let's see. I don't need to do this. We can do... Let's assume it's that way. So we do get pixel data color 32, y times data width plus x. Get pixel data. And then we can do... and then we can do... Yeah, what the fuck? And then we can do... Let's just do this for now, return. So we're gonna do byte a is equal to terrain patch, terrain data dot get value 32 x y 0. So we get the height value here, and then I want to do debug.log is equal to mathf inverse lerp between 0 and 255 and a. We read the value as a byte, convert it into a float between 0 and 1. Yeah. I guess they are a dragon. Although, like, what is the correct word I'm looking for? Like, I get a little bit interested, like who who jumps into random Twitch chats and posts there. I assume OnlyFans. I really want to. I want to understand that person, you know. Fluid point. Yeah, we're gonna. Okay, so what we can do now is that we can point somewhere on the terrain. We can press E and we will get the byte value as a float at that position, and we can compare it with this one, height 1. What did I call it? Height value. Height value. What the fuck? Oh yeah, of course. Because we terraformed with this one, yeah. And I want to do height value. Let's see, height value 1. Height value 1. Height value 0.247. Ooh. 2509. Yeah. Okay. Damn, I really need to remember this one right now. So, get pixel data, or let's say your pixel data in a texture is stored in row major order, right? We loop through the rows first. Yeah, that's it. Brother of a close friend works by doing shit like that, promoting and doing all work of OnlyFans girls. Okay. Answering DMs and stuff like that, that I can respect. But like jumping into random Twitch streams and just spamming links, I don't know. Damn, I actually, like, I have a hard time conveying how much this shit interests me. Like, just the fact to remake Fluid Point into something that uses way less data, and like converting between data represented by a lot of bits to data represent the same data with less bits and stuff like that. It's very interesting. Okay, so now we have this function, which is a beautiful. And this one is, yeah, we get the correct, like, since we're using RGBA 32 for this texture, we're getting the actual source data type representing this, or this texture is stored in. And this is way quicker than this, because in this one Unity first converts the underlying data to color, which uses float 32s per channel, and then And this one actually allocates memory. This one doesn't. That's very nice. Okay, fluid solver. We don't care about this anymore. So what do we have? Fluid point byte. Let's see here. Height. We want to represent it by byte. And we want to do terrain data dot value 32 x y 0. Is minima. Yeah, we're gonna clean this one up as well. Let's do byte, finding him byte, 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 byte. Could have done this, I suppose, but no, I want to get some errors here. Do we have that? Height plus height is byte, finding minima's fluid amount is byte. Is that true? Beautiful. Yeah, I also wonder. Efficiency. Oh. Oh. Yeah, this one I'm interested in. Yeah, it's lame. Yeah, it seems to be like that. Lupo. What's up, by the way? Yeah, that seems to be the case. Takes the same approach on the grounds of language backward compatibility. Fuck. So that basically means that fluid point byte is not going to be fluid point byte, because I guess that it would be more efficient to just work with integers in this one. If every time we do a comparison, any arithmetics, if we have to cast back and forth, aren't we better off by just rolling with int? And then when we get the end result, that's when we change it to byte. That sucks. C# most efficient way to add byte. Byte arrays. I don't care about byte arrays. The byte type in C# was not really intended to be used as a number, but a collection of bits. Not yet CoolerSK, I don't think. We'll see. But what the fuck? Byte. Okay, now it became a little bit more boring. Yeah, I guess we're better off just doing all the calculations with integer. Why can't you add 2 bytes C#? I want to get back to the... Or do we have it here? Yeah, we do. Do we have any official Microsoft? Fuck. Someone stated that it was because of backward compatibility. I wonder if it's more because of this case. Like, even if it was implemented, it might just be as costly as doing it with a 32 bits. But I don't know. If this is true, then never mind. When is this answer from? 2016. Yeah, like, initially I thought the case for it not being implemented was something like this. because I would much rather get this error while implementing this than seeing no performance nor memory gain whatsoever, if you know what I mean. Yeah, we can do this. We can get a value 32, store it. We can get a 8-bit. We can get a byte and store it in an int. Yeah, I guess we're gonna do it like this then. Is minima, we don't need error margin. I'm still gonna call it fluid point byte though, which may seem a little bit weird, but the end result is going to be a byte, so yeah. Or like internally it works with integers, but the entry and exit points will be byte, I think. Good, good. This one we want to rework, I think. Spire said var r, as we do bit shifts. I'm actually gonna need to copy that and look it up after the stream. R is equal high, low. Wait, can you do, let's see. Yeah, if we can compare bytes. But I guess something about using unsafe method. Yeah, I might. Yeah, I might actually research it, because if we could just do the, yes, we do the addition using byte magic, byte shift magic, and then we can actually compare them. Interesting. Add 2 bytes C# without hint casting. Well, that's not what I want to do. Yeah, gonna have to research that. So no memory difference here, we just work with integers instead of floats. I suppose that's good. For now. Everything is pretty much the same. Now to the question. I want to do this slowly. I want to see every part. Fluid point. Start point. Add finding minimus. Yes. Fluid amount here is byte. So if we do it as an int here. Then we can skip the cast here. We don't care about error margin. Then we start. We add. This one. I actually don't want that here. I want to clean this up while we're coding here. Calculate new fluid amount based on height difference. Fluid point byte is minima, get neighbor. Public int get fluid spread. To point. Source height, destination height, we don't need those, but point byte p. Source fluid amount, I don't think we need that one. Error margin, we don't need that one. We need the costs though. But they're going to be an int. Height difference, unfortunately. No. Int height difference is equal to ooh. Interesting. So we can't figure out if we're going downwards or upwards. Do we use height difference for anything else than this? No, we don't. So instead we're not going to calculate that one. We're not going to calculate fluid cost. Instead we do if p.height is bigger than if height is bigger than p.height, then we're moving downwards. Else if height is less than p height, then we're moving upwards. Else we're moving parallel to the ground. We can see here get fluid spread count, so return Yeah, we have multiple different fluid variables, so we're gonna do it like this. Get fluid spread cost. I'm probably going to rename those later on, but return 0 if we move upwards, return upwards, multiply cost. But actually, base cost plus height difference, yes. Yeah, okay, so if we move upwards, we know that this one is bigger than this one, so then we can do base cost plus oh, sorry about that. P height minus height. No risk of overflowing? Nah. Beautiful. Yeah, if we're working with bytes, we're gonna need to be able to do as soon as if we can define multiplication and addition and the subtraction, it's okay. Fuck, I want to do that sometime. Would be amazing. Get fluid spread cost. So instead we want to do P dot get fluid spread cost to N finding minima base cost and finding minima's byte. Yeah, we want to change the first one to byte as well. Then we remove this one, fluid spread cost, and then we can do P dot fluid finding minima fluid amount minus fluid spread cost. What the fuck? Can't convert from we don't need this one here. Here we do a base cost like this. I think we're gonna skip it. This is no range. Building graphs base cost. Building graphs. Oh no. Less than 0 we can't do. If new fluid amount is 0, but we we're working with integers. We have less than 0. That's another problem we're gonna have to deal with if we go purely byte. If, I don't know. Yeah. And then we have to do this again. New fluid amount. Is this final fluid? Don't we have these? We have this one. Ah, never mind. There's a reason we don't have them, because this one is 0. Very interested to see how this pans out. Fluid group. Huh? Okay. Interesting. Although, one last thing. What do we do in the end? We clear everything and then we build it here by getting fluid amount. Ooh, fluid group byte. No, fluid point byte. I'm a little bit worried about this one. Set raw fluid amount. We're anticipating here as well. We're anticipating a float value between 0 and 1. So edge fluid amount. This one is an integer. I guess we can do this for now. Math f dot inverse lerp between 0.255 and this one. What do we have? Environment minimal threshold fill byte. Yeah, we're off. Pretty cool, and I know why. Although I wonder. So when we do spawn fluid visualization object and add to dictionary, we have the building graphs fluid amount here. Here we have fluid point byte. Or we have fluid amount here, instantiate I also think we need to do one additional thing compared to this one. Okay, so I guess we can just do this right now. We can just do a similar mathf inverse lerp 0255. A little bit scared why we didn't get why the algorithm didn't continue, but I guess we'll find out. It continues. We have some issue with it. The first phase went great though. But not the second. This one works. This one does not. Unvisited nodes. fluid spread cost. Oh. What is it we want to check here? Oh, yeah. If p height minus n height is equal to 0, yeah. We never added anything to invalid end nodes. Could it be it? And here, if n building graph's fluid amount something like that. Yeah, we need to fix something for this one as well. But I guess this looks good. Why do we continue forever on this one? We have a base cost of 0. Should be okay. Yeah, this one I don't understand. Why doesn't this never end? Fluid spread cost. Could it be this? P height. No, it shouldn't be. Or actually, bigger than or equal. What the fuck? We're not working with floats anymore, so if it's equal, we don't want to add it. Of course. Well, we're always getting way less. Yeah, we're doing something wrong here, right about here. Or it could be this one. Yeah, the cost for moving down in parallel for the second one is way too big. So what if building graph space costs about 51, 20. Oh, beautiful. Beautiful. But does the end result here equal to... Do we still have a difference between end result and... Yeah, we have here. Yeah, the fuck is going on there? Hmm. Hmm. Yes, indeed, Glutax. Yes, indeed. Before we can change this into a mesh, I need to get to the bottom of what the fuck is happening with this one. Like green, the green squares and the final product should be the same. But The only difference is... Oh, I want to take care of... I want to find the reason for this one. When we draw the green ones, we do it with this one, so we don't give in a position. So then we just get position like this, and then fluid amount. Ooh, is the scale. Let's do this and do fluid amount 0.27, 0.08. Yeah, the fluid amount for this one is way less. Or way less. 4 times less. But then I guess this one has a bigger height as well. Yeah, it has. Let's see here. I wonder if the difference we see is just because the different way of visualizing stuff. And it might actually not be. Water 0.29. Although it looks hella weird. Why? Okay, we move up here, so we should lose some water. Yeah, some tiny tiny issue. It's not too bad though. Really? Maybe. Mm-hmm. I don't know. Okay, okay. Yeah, we filled this one up first. Mm-hmm. But look at this. It's fucked. I need to get to the bottom of that. The green one looks beautiful. It's when we convert it to actual data. That's when we get fucked. Because if we take a look at this one, I think this green one looks good. Oh, yeah, the green one looks good. But after that, I don't know what happens. Okay, so it's something with the conversion between. So the fault lies with this one, definitely. So when we take fluid amount here. Add fluid amount. Terrain patch, terrain data, raw height. Plus fluid amount. It could either be this one. Let's see. Or oh, could it be? Yeah, it's either here or here. But unfortunately I won't get to the bottom of it today because I gotta run real soon. So it basically comes down to it pretty much comes down to the conversion between having fluid amount as a value of how much fluid is at a certain point and having the fluid value represent what the fluid surface height is. And that conversion is not done correct. Either not done correct or visualized correct. But it could be this. Yeah, unfortunately I'll need to fix it tomorrow because I gotta run. But still, good progress today, so I'm happy. Thank you so much for watching, appreciate it. And have a great rest of the day. Peace.